have it in the form of audio, video, etc. So we have data in various formats. Now looking at this data and trying to give some kind of insights from the data. Now what could be the kind of insights? So, oh, is my screen not visible? I'm sharing. Okay, it is visible. I think someone are able to see it, so probably it should be a problem for others. So you can try to refresh the screen. Okay. So yeah. So from the data that is typically belonging to any of these categories, we are trying to draw some kind of insights from it. So though most of our class would be on this data, the structured tabular data, but in some kind of scenarios, we would I would introduce you to this text data, and I would also introduce you to this images data. But again, they are like very brief for one small use case or something like that, just to give you an introduction to each of these. But primarily all our models, because most of you should get comfortable at least with this dimension to start with. So I would be working with the tabular related data, right? And so our objective of analytics is to draw insights from the data. So drawing that insights is, initially it could be as good as your descriptive. Your analytics could be more and more descriptive in nature. So these are the things that you might have covered a little bit as a part of your statistics or quantitative methods kind of courses, right? So where you try to do some kind of, so in descriptive, you only describe the data. You only describe the historical data. So the descriptive could come in the form of some summaries. So you try to do some kind of summaries on the data. That summaries are sometimes basic data visualizations you would like to do, just to try to understand the data, right? Descriptive is primarily you create a kind of a report on what has happened. What has happened is what a report that you are creating. So we would be doing that in the part of this course also for one session or so, because at the end of the day, unless you understand the data, you cannot give some you cannot actually use the data for the prediction. Then once you are knowing about the descriptive, you can also do some kind of a diagnostic analysis. So the diagnostic is primarily coming from the perspective of your inferences. So inferential analysis also you can very well call it. So the inferences you are making based on the data. So these inferences probably are more statistical in nature. And if you remember, as a part of your statistical courses, you would have done some kind of various tests on the data, etc. Various statistical tests, whether it is your T test, F test. I hope that you are all comfortable doing all these various tests and making some kind of inferences from the data. And the third aspect that is the focus for us is making some kind of predictions. Is making some kind of predictions from the data, right? Once I make some small inferences, trying to build the relation here, the inferences are primarily the relationship between two variables, etc. Is this a significant relationship or is it an ignorable kind of a relationship? So once I build that, then I would be interested in building various predictive models, because that is what is very essential. The learning from the statistics is always like, reporting is a very small aspect for me, but more than the reporting, I should be able to create some kind of predictions on the data, and that is where we would be using the predict. So this is the part that is the scope for our current course. But of course, some of the predictive models you must have already used earlier, right? You must have used a simple linear regression or a multiple linear regression, or I'm not sure whether you have used a logistic regression, etc. But yes, these are some of the predictive models that you might have already used in your earlier courses as well. But we will be building on the top of them and see how predictions may be in some cases better when I am going for the other forms of learning models compared to these simple linear regression or a multiple linear regression kind of model. And then there are a few important other things in terms of prescriptive analytics. Right? In terms of prescriptive, it's more like a solution building where the optimization of the parameters, etc. So which is actually coming in the world of a sophisticated form of your operations research, etc. they are coming under the prescriptive analytics. So as a part of this course, our focus is primarily on this predictive analytics, though we would be using a little bit of this descriptive and diagnostic also, but the major focus of this course is on predictive analytics, generating some kind of predictions. So in this predictive analytics, or in the whole world of machine learning, we typically have problems that can be classified into what is called as a supervised learning and unsupervised learning. So we have supervised and unsupervised learning. So the supervised learning is where the actual prediction part comes in, right? In the whole world of machine learning, probably let me not call it predictive analytics here. In the whole world of machine learning, so the problems can be divided into a supervised learning problems and unsupervised learning problems. Though we have a few other categories as well, where we call semi-supervised learning, or we also talk about reinforcement learning. So reinforcement learning is a slightly different world, right? Probably all your current chatbots and all these embedded kind of applications, they use all the reinforcement learning. You talk about self-driven cars, etc. They are all the autopilots or unmanned vehicles, etc. They all come under the reinforcement. They use a reinforcement learning because there is an interaction with the external environment, and based on that there would be a kind of carrots or sticks, and based on that the overall end-to-end solution is visualized. But to go to that, you need to be very much comfortable to use either both the supervised and the unsupervised learning algorithms. So the supervised ones typically is the place where the actual prediction is going to happen, right? So basically it is like you would have your input variables as well as output variables from the historical data. Your historical data that you are using will have some input variables and will have one output variable, and your intention is to learn the relationship between these two. So how do you learn? There could be various ways of learning. So some people may say I will mug it up, some people may say no, I will remember in a very different format. Some people may say I will try to I'll try to read here and there, right? And based on that, I will try to make some kind of sense out of it. So there could be like the learnings that different people do could be different. So the relationship, there is an output, and in line with the output, the input needs to be understood. Input is some columns of data. Output is one single column of the data, that is our target. So that is the reason in this world, inputs are typically called as features and outputs are generally called as targets. So we would try to build a relationship between the features and the targets. So that is the objective. And once we have built a good relationship, it means I know what is the relationship between the targets and the features. Targets are generally unknown kind of things, right? Target is something that is unobserved or at this point. At this point, I don't know. So unknown or unobserved. And features are something for whose the value is already known now. Value is already known now when we are trying to build the model. Features, all features should have their value known. Whereas for the targets, their value should be unknown. That is when I am trying to predict them. If I already know that value, why should I predict it? The only thing is I don't know anything about it. I don't know what would be the value. So that's where I'm trying to predict. So all the supervised learning algorithms that we are going to look at, they would typically be doing some kind of a prediction. So probably we would be using different kinds of algorithms, right? And this prediction also, there could be primarily for this prediction, the most common problems are in the prediction, there are two most common problems. Again, I'm always going with the most common. So there are classification problems and there are regression problems. Classification problems are like, I am trying to do the prediction of a category, right? A category could be a good, bad, or my output is like yes, no, right? So those kind of categorical, not necessarily binary. It can be any multiple categories also, but I'm actually predicting a categorical variable. My output is a categorical variable. My target is a categorical variable. Whereas in a typical regression problem, my output is a numerical variable. In a regression problem, the output is a numerical variable. So don't get confused with simple linear regression and multiple linear regression that you have used, right? Because they are only one such kind of regression problem. So there are various other regression problems, and the research in this area is growing leaps and bounds. So some new algorithms can keep coming quite often. So that is my second. We are going to deal with a wide varieties of algorithms that fall under the classification as well as the regression. Then the other set of problems the machine learning is going to address is an unsupervised learning. So in this unsupervised learning, there is nothing called any kind of a prediction. We don't do any kind of a prediction here. We primarily look at, so which means you don't have an output in the historical data. All the data that you have is the input only. So there is nothing called output because I don't want to link it to anything. So it's an input only. So what is that we do in this? We only do pattern identification. You try to explore. So you try to identify different kinds of patterns in the data so that you can use that for some purpose later on. So the major part is pattern identification. So the pattern identification, one of the major examples that we talk about is the clustering, right? Or you will talk about what is called as dimension reduction. Probably in some of your courses, you must have used something called a PCA. So these are some of the things that fall under the pattern identification kind of aspects. So they go under the unsupervised learning algorithms. So we are going to deal with these things as a part of the current course. PCA, yeah, I'll take up the unsupervised learning. So within that unsupervised, I'm going to look into that. I mean, again, there would be some limitation on how deep we go into each of these aspects. But yeah, definitely we are going to cover it. And based on the questions that come up, I will see if I can cover that later, or sometimes, I mean, we can have some extra classes to go a little bit more deeper, or I can actually give you another reference to that as well. Yeah, I can typically cover the PCA also. I mean, we have a very simpler way to understand. Yeah, dimension reduction. PCA is one method of dimension reduction. So I'll to answer your question. PCA is one method of dimension reduction. We will talk about various feature selection methods also here. So which are the machine learning driven dimension reduction methods. PCA is purely a statistics driven dimension reduction method. All right. And it's a linear method. So semi-supervised learning is as simple. I mean, you have your data where for some of them you have output, and for some of them you don't have the output. For some inputs you have the output, for some inputs you don't have the output. So what you typically do is initially you take the supervised, you apply the supervised learning on the data where you have the output, and you would typically try to do the projection on the data where you don't have the output. And the other thing is you would also do an unsupervised learning on those data where you don't have the output by doing some kind of cluster analysis, and try to compare the predictions that are coming out from the data where using the supervised learning. And based on this comparison, based on the accuracy that is being generated by the unsupervised learning algorithm versus the supervised learning algorithm, we will come out with some kind of combined model building. So I'll explain. I mean, I think we are not covering, but again, I'll explain it in a little bit more detail once we do both of them, so that you can understand it much more clear. I think some more questions are coming up. So again, before I move further, so this is what is our scope. Now I'll take up one small data set so that I don't want to just finish out the class without any practical hands-on. In unsupervised learning, the model will not give predictions, or we cannot predict both. The models do not give any predictions, right? Because there is no target. Because there is no target, the learning is, so it's as good as saying in a supervised learning, the learning has an objective. I have to maximize my chances of predicting that output correctly. I have to link input and output. So that is what is my target in supervised, which means I have something to, I have a guided learning. That's a guided learning. Whereas in unsupervised, I don't have anything to predict. So no guided. I'm very much open. Identify the patterns. Probably if you talk about fraud identification, I don't know what is a fraud and I don't know what is not a fraud. So my objective is it's an open. Just try to do something on the data and try to extract some patterns out of the data where these records are different from the other records. So which means there is some kind of a sensing. So there is some kind of a possibility that there is something wrong with these records. So basically it's like you are using your imagination. Sometimes I say when supervised learning is a scientific way of trying to bind the input and the output, or a science side of machine learning, unsupervised learning is an art form of machine learning, right? So that is the way I try to differentiate. Again, there could be various views on that, but I would typically prefer looking at it that way. For what objective if there is no output? Yes. So as I gave you an example, I need to do a customer segmentation, right? I have a big list of customers. I really want to really distribute them into multiple groups based on their various criteria, based on their spending patterns or based on their demographic characteristics, whatever. Right? I want to group them in such a way that someone who are very close to each other, or even stocks. In my finance class, I typically look at it. So there are the 1,000 stocks that are being traded on the stock exchange. Now, I mean, I'm just taking, or let's say there are 50 stocks that are a part of Nifty. Now, I really want to know out of these 50 stocks, which of them are very close to each other. Means this stock, if this grows, even this also grows more or less by a similar manner. So which of them? So which means their behavior or their characteristics are very much similar. Whereas some of them are very much different from each other. So again, my practical application is sometimes while creating a kind of a portfolio, or probably I'm using a finance example here. Sometimes while creating a portfolio, the suggestion is don't put all your eggs in one basket, which means, and also don't try to diversify as much as possible. Now, theoretically, what people say, what is diversification? Don't choose one single industry. So if you have invested, these are the theoretical side. So if you have chosen Infosys as one of your investment, don't invest in TCS. Better go and invest in Reliance. Now, I don't know whether, I am more interested in seeing whether the data is giving me that pattern or not. Right? And probably it might be possible that the most closest stock to Infosys might not be TCS, but it might be let's say some Coal India. I don't know, for whatever reason, right? My data is telling that, but my theory is not telling that. So if that is the case, I might not want to invest in Infosys as well as in Coal India together, right? Because my data is saying that these two are very close. And how can I know that? I'm doing a pattern identification to do that. So the pattern identification has many such kind of applications. Or a second example, right? You go to a store, right? So you have done a set of transactions. You have bought, let's say you went to a provisional store and you have purchased, or a supermarket, and you have purchased a set of items. So like that, I analyze the bills of let's say some 1,000 customers, and I try to identify some kind of a pattern. Yeah, the guys who have typically purchased this Haldiram products, they have also purchased this ice cream also together. So in most of the bills, along with Haldiram products, probably let's say some milk-related products or curd-related products are also there. So that's a kind of a finding that I got from a pattern. So from a pattern, I see that majority these two products are always bought together. So that is the kind of unsupervised pattern learning that I have got from the data. Now, what people can very well do, because this kind of observation is there, the supermarket guys can really try to place these two things next to each other. Or they can bundle these two products and then say, yeah, if you buy both of them, there could be some discount. Some such kind of weird combinations can very well be created, right? Because the pattern is either grouped or it can be separated. So that is what is the application. I hope you have got it. And when we do it a little bit more detail, yeah, I think we can go a little bit more detail in it. Predictive insights and prescriptive insights. So predictive insights are purely by applying the algorithms. We are getting a projection. So when you are giving a predictive insight, the output is like a prediction value. Whereas when you are giving a prescriptive insights, it is a kind of an optimization. So basically, you are giving a kind of a what if analysis scenario also. So if this goes to this is what is the output. If the inputs goes to this is what is the output. So basically, you are giving multiple scenarios, and under each of the scenario, what is the kind of your optimal solution. So that is what is the extension that a prescriptive analytics is bringing beyond the predictive analytics. Nagaraju, I am very, very sorry. I don't think we can cover the reinforcement learning in this class. Again, I mean, right now itself, this class is slightly more packed. But I can provide you some references. That's the only thing I can do. I'm really sorry for that. Then can we say that unsupervised learning is not predictive analytics as such? You are very, very right. right? But because we have to cover, basically we named it as predictive. That's the reason majority of our class is focused on predictive analytics only. 1 or 2 classes I am bringing it from the unsupervised learning, because our class is not machine learning. Our course is primarily predictive analytics. So the predictive analytics can use the mechanisms not necessarily from the machine learning world, even from a statistical world also. The predictive analytics can very well use, because the objective is to predict something. Vikas is very right. Unsupervised learning does not fall under the predictive analytics scope at all. If there is a pattern as input, and if we need to predict the pattern, that will be considered as, if there is a pattern as input and we need to predict the pattern. So the next pattern, if we have to predict it, then it becomes a supervised learning. So wherever there should be an input and an output. When you are saying supervised learning, there should be an input and output both as a part of the data. And the output should be an unknown thing, input should be a known thing. So only then you can build predictive learning models around them. Okay, identification of patterns is the objective. That is very, very right. Got it. The output is to study the similarity or diversity. Very right. Market basket analysis is an example of unsupervised learning. So, but it is coming from the statistical world by using the concepts of support, then lift, and all these kind of concepts. So, if you have already done it, great. We would cover a little bit of it, but again, I don't think. I am only covering the clustering and dimension reduction. Market basket analysis is another form of unsupervised learning called association rule mining. So, market basket analysis is an application. The actual concept is called association rule mining. So this is also another form of unsupervised learning itself. Yeah, I think Lakshmi has already given the answer to it. Okay, I think I'll go a little bit further. I just want to show the practitioner's way that I'm going to take up. In decision tree, support and lift were covered. Fine. So decision tree, support and lift. Yeah, fair enough. Okay. Now I'll come back to the Python data file. So this is how we are going to proceed always. Once you install Python, so in case you are not able to, probably you can take the support of many other friends who are able to install it. So the best thing is we will install these as the required libraries that we are going to work with. So we will be using NumPy for mathematical calculations. We will be using Pandas for data operations, Seaborn for generating good data visualizations. Of course, those required for our class. Then Matplotlib for basic visualizations, which is again, Seaborn is a package that is built on the top of Matplotlib. So these are some of the codes that you can simply blindly copy also, right? So then it is the stats models for typically doing some kind of linear regressions and all. We are going to use stats models. And so these are some of the packages, and SciPy for any kind of statistical, again for some kind of statistical data analysis, some kind of descriptive statistics, etc. We would be using them. So you can simply copy this code from the notebook that I'm going to share with you. You can copy this code and you can execute this. You can run this. So once it runs, once the number comes here, it means that it has run quite comfortably. So you can copy this lines of code into your Jupyter notebook after you have done your installation. I'll share this Python code with you. In fact, this code I have prepared for the next 5-6 classes also, or 6-7 classes, right, where the entire classification problem has been addressed here. But yes, I would try to incorporate a few more functions into it so that the entire learning would be more comprehensive. So I would be updating the same notebook every week, and any kind of modifications that are made, I would be circulating it to you. So I would be using one data set called heart. Now, what is this data set doing for me? My objective here is to predict whether a person will have heart attack or not, whether a person will get a heart attack or not. Now, so because the output is to predict whether the person will get a heart attack or not. So output is a categorical variable that way. The output is a categorical variable, and hence this problem should be a classification problem, right? Now, what are the inputs? Now, I typically, if I have to really solve it the problem way, I have to go to an expert in this medical field and try to ask him or her what are the various drivers of heart attack. So they gave one, age could be a driver, or someone might say blood pressure could be a driver, or someone else might say the diabetes could be a driver, or someone else may say cholesterol could be a driver. Like that, I am actually collecting for the various variables that would really influence or that could really differentiate whether this person will get a heart attack or not. So this is what, and I will have to collect the data regarding this. So these data are my features. So I have to collect various features which can really help me in predicting the target. So because here we are not collecting the data on our own, I am taking the data that is already available in the public domain for some that has been collected for some other purpose. So I am taking one data called heart.csv, which contains this information for around some 900 plus patients. For various 900 related patients, we have said the feature is for those people whether they got a heart attack or they did not get a heart attack. That was one of the features. And that was the target. So I have the data relating to that. And for those people, I'm getting the various other details regarding their age, blood pressure, etc. So that is what is the content of this data set. So if you look at it, so I am loading this data set. This is their heart.csv is the data that I have. It's an Excel file or CSV file. I am loading that data set. I am loading it by using all data related operations are done using pandas. So I have imported pandas library. Libraries are some group of functionalities. I have imported the pandas library as a PD. PD is a kind of a shortcut that I have used for the pandas. So I'm saying from pandas, read CSV. So wherever you want to read a CSV file, this is the kind of a mechanism you are going to use. So I am reading this and I am storing it in a variable called heart. So heart is a kind of Python variable that I am creating where the entire CSV file, which I am reading using the pandas library, I am reading this heart.csv and I am storing in this variable called PD. Yeah, PD is the alias for pandas. Yeah, because here I have written, if I don't write it like this, if I simply say import pandas, every time I have to say pandas.read CSV. So the most common thing you will find in the codes, anywhere you look at in the open space, you will find import pandas as PD. So I am reading this heart file. So a quick 1 or 2 lines. If I really want to know how many rows are there in the data, so yeah, what is the default path it is picking? Wherever your Jupyter Notebook environment is set up, I have pasted that data file also into the same location. Otherwise, you have to give the complete path d:// So you can take the path and you can paste it here as well. But most of the time, what I say is you copy the same pandas file. You can copy the same data file into the same location as your Python environment. Okay. So I can quickly look at what is the number of rows of that file. So I'm saying length. Length is a function to get the number of rows. These are all coming from pandas. And if I really want the shape of the data file, how many rows and columns, so I can run this. So it is saying it is having 918 rows and 12 columns. Is Python Anaconda different than Jupyter? Yeah, Python Anaconda framework contains Jupyter as one of the editing environments. Python Anaconda is a framework where multiple all these libraries are coming as one single installation. Otherwise, you have to install Python separately, install NumPy separately, Pandas separately, etc. But if you are doing an Anaconda installation, then all these are installed along with the Python itself. And it also comes with an the environment called Jupyter Notebook. So once you try installing, within that itself, within the Python, within the Anaconda framework, you will find the Jupyter as such. Okay. So anything I can continue for the next class. I think we are almost coming to the end of this session. So you can post your doubts on that Telegram group that we are going to construct, so that before the next class, these kind of things are typically clear. Thanks a lot for everyone to listening to this session. We'll again meet up the next week. Thank you very much. Take care. Bye.